You've probably heard a ton about smart contracts and how they're going to change everything. But what if the very thing that makes them so powerful is also their biggest weakness? Behind all that promise of automated, trustless agreements, there's this hidden catch, a challenge that could bring the whole system down. It's called the Oracle problem, and we're going to break it all down.
Just think about it for a second. Contracts that literally execute themselves. An insurance policy that pays you out the instant your flight gets delayed. No phone calls, no paperwork. Or a financial deal that settles on its own without any middleman taking a cut. I mean, this is the incredible potential of smart contracts. They're just pieces of code living on a blockchain, and they're designed to be completely unstoppable and tamper-proof.
But, and this is a big but, here's the catch. The best way to think about a blockchain is like a super secure, isolated island. It's its own little universe. It knows everything happening on the island with absolute perfect certainty, but it has zero idea what's happening in the outside world. It can't look up flight data or check stock prices or see who won the game last night. It is completely, totally sealed off.
So you're probably thinking, why on earth would you build a system with such a massive limitation? It seems like a huge design flaw, right? Well, it turns out this isolation isn't a bug at all, it's a core feature. And this is the blockchain's big dilemma. Its greatest strength, its security, comes directly from being so isolated.
See, by being cut off from the outside, every single computer on the network can agree on one single shared truth. That's what strong consensus is all about. It's how every transaction gets validated, and, this is the really important part, it's what prevents fraud, like double spending, where someone tries to spend the same digital coin twice. That level of security is only possible because of this sealed-off design.
Okay, so this brings us right to the heart of the issue. If our flight insurance contract needs to know if a flight was delayed, how in the world does it get that information from the real world onto its secure, isolated little island?
The answer? Well, it requires a special kind of infrastructure. To solve this Oracle problem, we literally need to build a secure bridge from the blockchain's island to the mainland of the real world. And in the world of crypto, that bridge has a name. It's called an oracle.
Now let's be super clear here. An oracle isn't some person with mystical powers. It's a service, a piece of tech that basically acts as a secure data messenger. Its entire job is to go out, find and verify real-world data, and then feed it onto the blockchain in a language that the smart contracts can actually understand and use.
So here's how that whole process actually works. First up, the Oracle is always listening for a request from a smart contract, like, hey, I need that flight delay info. Then it goes out and extracts that raw data from an off-chain source, maybe the airline's official API. Next, that data gets formatted into a language the blockchain can read. And here's the crucial part. The Oracle has to validate that the information is accurate. Once it's confirmed, it computes and broadcasts the final data onto the blockchain itself. And finally, that verified info is output to the smart contract, triggering the insurance payout. Boom!
But, not all bridges are built the same. And the very first attempt to solve this Oracle problem, well, let's just say it created a brand new and pretty massive flaw in the system.
This right here is a centralized Oracle. It relies on just one single entity, one node, to be the only source of information. So all of that critical real-world data has to funnel through this one single point before it ever reaches the decentralized blockchain. You can probably see where this is going.
And that leads us directly to this huge problem. A centralized Oracle is a single point of failure. I mean, think about it. If that one source gets hacked, or feeds it bad data, or even just goes offline, the smart contract that relies on it is either going to fail, or even worse, execute incorrectly. It basically brings back the very problem that blockchains were invented to solve in the first place.
Which, of course, begs the question, doesn't having a single point of failure completely defeat the entire purpose of a decentralized, trustless system? And the answer is, yeah, absolutely. You can't build a secure, decentralized house on a fragile, centralized foundation. It just doesn't work. Thankfully, this really obvious flaw led to a much better solution. A bridge that was actually built using the same principles as the blockchain itself. A truly decentralized solution for a decentralized world.
And this is what that looks like. This is a decentralized Oracle network. So instead of one node, you have a whole network of independent nodes. And instead of one data source, it's pulling information from many different reliable sources. This is all about strength in numbers.
By combining all these different nodes and pulling from all these different data sources, you completely eliminate that single point of failure. If one source is wrong, the others can overrule it. The network comes to an agreement, a consensus, by gathering all the data and kicking out any weird outliers.
This is how you get true end-to-end decentralization, and how you create that secure, trustworthy bridge that the Web3 world really needs.
So we have decentralized oracles, and we've got a secure bridge for perfect data. Problem solved, right? We're all good? Well, not so fast. Because even if you have perfect data, you still have to deal with imperfect code. Technology is just one piece of this puzzle. We also have to think about the human element.
At the end of the day, you have to remember a smart contract is just code. And that code is only as good as the developer who wrote it. A poorly written contract that gets perfect information is still going to execute poorly, and that could lead to some massive, massive problems.
And that's why securing a smart contract takes two totally different but equally critical steps: testing and auditing. Testing, which is done by the developers, just proves that the code works the way they intended it to. But auditing, which is done by outside security experts, proves the code is actually secure from attacks. And you absolutely, positively need both, because a contract can work perfectly as intended and still be wide open to being exploited.
This whole situation leads to this fascinating and kind of tricky dilemma that people call the code is law conflict. What happens when a contract works perfectly, exactly as it was written, but the code itself had a flaw or was even malicious? I mean, technically, the computer did its job, but if the real-world result is a total disaster, who's to blame?
It's really important to zoom out for a second and remember that oracles are just one piece of a way bigger puzzle. The whole Web3 ecosystem is this huge, complex stack of brand new technologies, everything from decentralized storage to new kinds of browsers. We have really only just scratched the surface of one single component today.
And because this whole new world is so complex and so new, and because it's so closely tied to finance, it's absolutely essential that we end with a crucial reminder about the risks involved.
It's just vital to remember that this entire space is incredibly volatile and comes with a lot of inherent risk. There is simply no way to guarantee that the value of any cryptocurrency or digital token today will hold up in the future.
Which brings us right back to our final question, and honestly, it's one that has no easy answer. In this new world where automated code controls billions of dollars, if code is law, then who is truly responsible when the law itself is wrong? That's a question we're all going to have to grapple with as this technology keeps evolving.